Welcome to our exploration of Earth as a living system. In this video, we'll dive into the interconnected processes that make our planet function like a vast organism. From the atmosphere to the oceans, every component plays a vital role in maintaining balance and supporting life. We'll see how energy flows, matter cycles, and how life itself influences the planet's dynamics. Understanding Earth as a living system helps us appreciate the complexity and beauty of our world. Let's begin by looking at what makes Earth unique among planets and why scientists describe it as a living system. Earth stands out in the solar system due to its ability to support life. Its atmosphere, abundant water, and moderate temperatures create a hospitable environment. The planet's magnetic field protects it from harmful solar radiation, while its diverse ecosystems foster a wide range of organisms. These features are not isolated, they interact continuously, shaping the planet's living system. As we move forward, we'll see how these unique characteristics contribute to Earth's dynamic balance and resilience. The Gaia hypothesis, proposed by James Lovelock, suggests that Earth functions as a self-regulating system. According to this idea, living organisms interact with their environment to maintain conditions suitable for life. For example, plants help regulate atmospheric oxygen and carbon dioxide levels, while microorganisms influence soil and water chemistry. This hypothesis has inspired new ways of thinking about planetary health and the interconnectedness of life and environment. Earth's atmosphere is more than just a blanket of gases. It's a dynamic system that regulates temperature, distributes energy, and protects life. The atmosphere allows sunlight to reach the surface, while greenhouse gases trap heat, maintaining a stable climate. It also acts as a shield against meteors and harmful radiation. The movement of air masses drives weather patterns, which in turn influence ecosystems and human activities. Understanding the atmosphere's role is key to grasping Earth's living system. The water cycle is a fundamental process that connects the atmosphere, land, and oceans. Water evaporates from surfaces, forms clouds, and returns as precipitation. This cycle distributes heat, shapes landscapes, and sustains life. Rivers, lakes, and groundwater provide habitats and resources for countless organisms. The water cycle also influences climate and weather, making it a central element of Earth's living system. The sun is the primary source of energy for Earth's living system. Solar energy drives photosynthesis, powers weather, and fuels ocean currents. Plants convert sunlight into chemical energy, forming the foundation of food webs. This energy flows through ecosystems, supporting all forms of life. The balance between incoming and outgoing energy determines Earth's climate and stability. Photosynthesis is the process by which plants and some microorganisms convert sunlight into food. This process not only provides energy for growth, but also releases oxygen into the atmosphere. Photosynthesis forms the basis of most food chains, linking the energy of the sun to all living organisms. Without it, life as we know it would not exist. It's a perfect example of how Earth's living system relies on interconnected processes. The carbon cycle describes how carbon moves through Earth's atmosphere, biosphere, oceans, and geosphere. Plants absorb carbon dioxide during photosynthesis, animals release it through respiration, and decomposers return it to the environment. Oceans store vast amounts of carbon, while volcanic activity and fossil fuel use add carbon to the atmosphere. This cycle is crucial for regulating climate and supporting life. Nitrogen is essential for life, but most organisms cannot use it directly from the atmosphere. The nitrogen cycle involves bacteria converting atmospheric nitrogen into forms plants can absorb. Animals obtain nitrogen by eating plants, and decomposers return it to the soil. This cycle supports growth, reproduction, and ecosystem health, highlighting the interconnectedness of Earth's living system. The biosphere encompasses all living organisms on Earth, from microscopic bacteria to giant whales. It interacts with the atmosphere, hydrosphere, and geosphere, forming a complex web of life. The biosphere's diversity ensures resilience and adaptability, allowing life to thrive in changing conditions. This interconnected network is a key feature of Earth's living system. Ecosystems are communities of organisms interacting with their physical environment. These interactions include food webs, nutrient cycles, and energy flows. Each ecosystem, from forests to coral reefs, contributes to the planet's overall health. The balance within ecosystems is vital for maintaining Earth's living system, as disruptions can have far-reaching effects. Feedback loops are processes where changes in one part of the system affect other parts, either amplifying or stabilizing effects. For example, melting ice reduces sunlight reflection, warming the planet further. Positive feedback loops can accelerate changes, while negative loops help maintain stability. These loops are essential for understanding how Earth's living system responds to internal and external influences. Humans are a major force in Earth's living system. Our activities, such as agriculture, industry, and urbanization, alter natural cycles and ecosystems. Pollution, deforestation, and climate change challenge the planet's balance. However, humans also have the power to restore and protect Earth through sustainable practices. Understanding our impact is crucial for ensuring the health of the living system. Earth's climate is regulated by a combination of atmospheric, oceanic, and biological processes. Greenhouse gases, ocean currents, and vegetation all play roles in maintaining temperature and weather patterns. Disruptions to these processes can lead to extreme events and long-term changes. Climate regulation is a prime example of how Earth's living system maintains balance. Oceans cover most of Earth's surface and are vital for regulating climate. Ocean currents distribute heat, nutrients, and gases, influencing weather and supporting marine life. These currents connect distant regions, making the oceans a global conveyor belt. Their role in Earth's living system is essential for maintaining stability and supporting biodiversity. Soil is the foundation of terrestrial ecosystems. It forms through the breakdown of rocks and organic matter, providing nutrients for plants and habitats for organisms. Soil supports agriculture, filters water, and stores carbon. Its formation and health are influenced by climate, organisms, and human activities, making it a key part of Earth's living system. Plants and animals depend on each other for survival. Plants provide food and oxygen, while animals aid in pollination and seed dispersal. These relationships form the backbone of ecosystems, ensuring energy flow and nutrient cycling. The diversity of plant-animal interactions strengthens Earth's living system, making it more resilient to change. Microorganisms, such as bacteria and fungi, are invisible but essential players in Earth's living system. They decompose organic matter, recycle nutrients, and influence soil and water quality. Some microorganisms form symbiotic relationships with plants and animals, supporting health and growth. Their activities drive many of the planet's key processes. The hydrosphere includes all water on Earth, from oceans to glaciers. It interacts with the atmosphere and biosphere, shaping climate and supporting life. Water is essential for chemical reactions, transport, and temperature regulation. The hydrosphere's movement and distribution are central to Earth's living system. The geosphere consists of Earth's rocks, minerals, and landforms. It provides the foundation for ecosystems and influences climate through volcanic activity and mountain formation. The geosphere interacts with other spheres, shaping landscapes and affecting nutrient cycles. Its dynamic processes are integral to Earth's living system. Earth's magnetic field is generated by movements in its core. This field protects the planet from solar, wind, and cosmic radiation, preserving the atmosphere and supporting life. It also guides animal migration and influences navigation. The magnetic field is a subtle but vital component of Earth's living system. Earth's living system is built on the interaction of its spheres: atmosphere, hydrosphere, biosphere, and geosphere. These spheres exchange energy and matter, creating feedback loops and supporting life. Their interconnectedness ensures stability and adaptability, allowing Earth to respond to changes and challenges. Energy and matter constantly cycle through Earth's living system. Solar energy drives photosynthesis, while nutrients move through food webs and biogeochemical cycles. These cycles connect all parts of the planet, ensuring resources are available for life. The balance of these cycles is crucial for planetary health. Earth's living system has mechanisms for self-regulation. Processes like climate feedback, nutrient cycling, and ecosystem resilience help maintain stability. When disruptions occur, the system can adapt or recover, though some changes may be irreversible. Self-regulation is a hallmark of living systems and is vital for Earth's long-term health. Biodiversity refers to the variety of life on Earth. High biodiversity increases resilience, allowing ecosystems to recover from disturbances. It also provides resources, medicines, and ecosystem services. Protecting biodiversity is essential for maintaining Earth's living system and ensuring its continued health. Adaptation and evolution are processes that allow life to thrive in changing conditions. Organisms develop traits that help them survive, and over time, species evolve to fit their environments. These processes drive diversity and resilience, shaping Earth's living system and its ability to respond to challenges. Carrying capacity is the maximum population size an environment can sustain. It depends on resources, space, and environmental conditions. When populations exceed carrying capacity, resources become scarce, leading to competition and decline. Understanding carrying capacity helps manage Earth's living system sustainably. Resilience is the ability of Earth's living system to recover from disturbances. Natural disasters, climate shifts, and human impacts test this resilience. Diverse ecosystems, Feedback loops and adaptive processes help the planet bounce back. Building resilience is key to sustaining Earth's health. Despite its resilience, Earth's living system has vulnerabilities. Pollution, habitat loss, and climate change can disrupt cycles and reduce biodiversity. Some changes may be irreversible, threatening planetary health. Recognizing vulnerabilities helps us take action to protect and restore Earth's living system. Restoration involves repairing damaged ecosystems and cycles. Reforestation, wetland recovery, and pollution reduction are examples of restoration efforts. These actions help rebuild resilience, restore balance, and support biodiversity. Restoration is a vital part of maintaining Earth's living system. Monitoring Earth's living system involves tracking changes in climate, biodiversity, and ecosystem health. Scientists use satellites, sensors, and field studies to gather data. This information guides conservation and management efforts, helping us respond to challenges and protect planetary health. Managing Earth's living system requires balancing human needs with environmental health. Sustainable agriculture, renewable energy, and conservation are key strategies. Effective management ensures resources are available for future generations and maintains planetary balance. Education is essential for understanding and protecting Earth's living system. Teaching about cycles, feedback loops, and human impact empowers people to make informed decisions. Education fosters stewardship and inspires action to sustain planetary health. Innovation drives new solutions for sustaining Earth's living system. Technologies like renewable energy, efficient agriculture, and ecosystem restoration help reduce impact and restore balance. Innovation is key to adapting to challenges and ensuring planetary health. Cooperation among nations, communities, and individuals is vital for protecting Earth's living system. Shared goals, policies, and actions help address global challenges like climate change and biodiversity loss. Cooperation strengthens resilience and supports planetary health. Earth's living system faces many challenges, including climate change, pollution, and resource depletion. Addressing these issues requires understanding their causes and effects and taking coordinated action. Challenges test the resilience of the planet, but also inspire innovation and cooperation. Solutions for sustaining Earth's living system include conservation, restoration, and sustainable development. These approaches help protect biodiversity, restore balance, and ensure resources for future generations. Solutions require creativity, cooperation, and commitment. The future of Earth's living system depends on our actions today. Sustainable practices, innovation, and cooperation can ensure planetary health and resilience. By understanding and respecting the interconnectedness of Earth's system, we can build a brighter future for all life. In summary, Earth functions as a living system through interconnected cycles, feedback loops, and diverse life forms. Its resilience and adaptability are shaped by natural processes and human actions. Protecting and sustaining Earth's living system is essential for planetary health and the well-being of all life. Reflecting on Earth as a living system reveals the beauty and complexity of our planet. Every process, from photosynthesis to ocean currents, contributes to the balance and health of the whole. Our understanding and stewardship are crucial for sustaining this remarkable system. Earth's living system inspires awe and responsibility. Its interconnectedness reminds us of our place within the web of life. By learning from nature and respecting its limits, we can contribute to planetary health and ensure a thriving future. Understanding Earth as a living system calls us to action. Protecting biodiversity, reducing impact, and supporting restoration are vital steps. Each person can make a difference, contributing to the health and resilience of our planet. Our legacy depends on how we care for Earth's living system. By fostering sustainability, innovation, and cooperation, we can leave a healthy planet for future generations. The choices we make today shape the world of tomorrow. Celebrating Earth's living system reminds us of its wonders and importance. From vibrant ecosystems to powerful cycles, every aspect deserves appreciation. Let's cherish and protect our planet, ensuring its health and vitality for all life. In conclusion, Earth operates as a living system with countless processes and interactions sustaining life. Its resilience, adaptability, and beauty are shaped by natural cycles and human stewardship. By understanding and respecting this system, we can ensure a healthy planet for generations to come. Welcome to our exploration of water's profound impact on life and civilization. Water is more than just a substance. It's the foundation of existence on Earth. From the tiniest microorganism to the largest mammal, every living thing depends on water for survival. In this video, we'll journey through the ways water supports life, shapes landscapes, and influences human societies. We'll uncover how water's unique properties make it essential for biological processes and how its abundance or scarcity has determined the fate of civilizations throughout history. Let's dive in and discover why water is truly the lifeblood of our planet. Water is remarkable for its unique physical and chemical properties. Its ability to dissolve countless substances makes it the universal solvent essential for transporting nutrients and waste within living organisms. Water's high heat capacity helps regulate temperatures, making Earth's climate stable enough for life. Its solid form, ice, floats on liquid water, protecting aquatic life during cold seasons. These characteristics are not just scientific curiosities, they are the reasons why life thrives on Earth. Understanding water's properties helps us appreciate its role in sustaining ecosystems and supporting civilization. The story of life on Earth begins with water. Scientists believe that life originated in the oceans, where water provided a stable environment for complex molecules to form and interact. Water's ability to dissolve and transport chemicals enabled the first cells to develop. Even today, all known life forms require water to survive. Without water, the intricate chemistry of life simply wouldn't be possible. This connection between water and life is fundamental, reminding us that water is not just a resource, it's the cradle of existence. Water is involved in nearly every biological process. It's the medium in which cells operate, enabling reactions that sustain life. Water helps transport nutrients, remove waste, and regulate body temperature. Plants rely on water for photosynthesis, turning sunlight into energy. Animals depend on water for digestion, circulation, and respiration. The presence of water in living organisms is so vital that even a small shortage can threaten survival. By understanding water's role in biology, we see how it connects all forms of life. Ecosystems depend on water to function. Rivers, lakes, and oceans provide habitats for countless species. Wetlands filter pollutants and offer refuge for birds and amphibians. Forests rely on rainfall to grow and sustain wildlife. The distribution of water shapes the diversity of life in different regions. When water is abundant, ecosystems flourish. When it's scarce, they struggle. Protecting water sources is crucial for maintaining healthy ecosystems and preserving biodiversity. Water is a powerful force in shaping Earth's landscapes. Rivers carve valleys, glaciers sculpt mountains, and rainfall erodes rocks. Over millions of years, water has created some of the planet's most stunning features, from deep canyons to fertile plains. These changes influence where plants and animals live and where humans build their communities. Water's ability to transform the land is a reminder of its dynamic role in Earth's history. Water plays a central role in Earth's climate. Oceans absorb and release heat, influencing weather patterns. The water cycle evaporation, condensation, precipitation regulates temperature and distributes moisture across the globe. Changes in water availability can lead to droughts or floods, affecting agriculture and human settlements. Understanding water's impact on climate helps us predict and prepare for environmental changes. The water cycle is a continuous process that moves water through the environment. Water evaporates from oceans and lakes, forms clouds, and falls as rain or snow. This cycle replenishes freshwater supplies and supports life everywhere. The water cycle also helps regulate climate by moving heat and moisture around the planet. It's a perfect example of how water connects all parts of the Earth's system. Agriculture relies heavily on water. Crops need regular irrigation, and livestock require clean drinking water. Ancient civilizations developed irrigation systems to harness rivers and streams, transforming arid regions into fertile farmland. Today, water scarcity threatens food production in many parts of the world. Efficient water management is essential for sustainable agriculture and food security. The earliest civilizations arose near rivers and lakes. The Nile, Tigris, Euphrates, and Indus rivers provided water for drinking, farming, and transportation. These water sources enabled communities to grow, trade, and develop complex societies. Access to water was a key factor in the rise and fall of ancient civilizations, shaping their history and culture. Waterways have always been vital for trade and transportation. Rivers, lakes, and seas allowed people to move goods and ideas across great distances. Ancient merchants used boats to connect cities and cultures, fostering economic growth and cultural exchange. Even today, major cities are often located near water, highlighting its ongoing importance for commerce. Cities have historically been built near water sources. Rivers and lakes provided drinking water, sanitation, and transportation. Urban planners designed aqueducts and canals to bring water into growing cities. The availability of water shaped the layout and expansion of urban areas, influencing population growth and economic activity. Water has inspired technological innovation throughout history. Ancient engineers built wells, aqueducts, and irrigation systems to manage water resources. Watermills powered industries, and steam engines revolutionized transportation. Today, technology helps us purify, distribute, and conserve water, ensuring its availability for future generations. Water scarcity is a growing challenge for many communities. Droughts, pollution, and overuse threaten freshwater supplies. Millions of people lack access to clean water, affecting health, education, and economic opportunities. Addressing water scarcity requires cooperation, innovation, and sustainable management. Pollution threatens water quality worldwide. Industrial waste, agricultural runoff, and untreated sewage contaminate rivers and lakes. Polluted water harms ecosystems and endangers human health. Efforts to reduce pollution include better waste treatment, stricter regulations, and community education. Conserving water is essential for sustainability. Simple actions like fixing leaks, using efficient appliances, and reducing waste can make a big difference. Communities and governments promote conservation through education and incentives. Protecting water resources ensures that future generations can thrive. Clean water is vital for health. It prevents disease, supports hygiene, and enables proper nutrition. Access to safe drinking water reduces illness and improves quality of life. Public health initiatives focus on providing clean water and sanitation to communities around the world. Water is a source of energy. Hydroelectric dams convert flowing water into electricity, powering cities and industries. Water is also used in cooling systems and energy production. Renewable energy technologies rely on water to reduce carbon emissions and combat climate change. Water has deep cultural significance. It appears in myths, rituals, and art across civilizations. Many cultures celebrate water through festivals and ceremonies, recognizing its importance for life and prosperity. Water shapes identity and connects people to their environment. Water is sacred in many religions. It symbolizes purity, renewal, and life. Rituals like baptism, ablution, and pilgrimage often involve water. Religious traditions teach respect for water and encourage its protection as a divine gift. Artists have long been inspired by water. Paintings, sculptures, and literature capture its beauty and power. Water scenes evoke emotion and reflect the relationship between humans and nature. Artistic expressions remind us of water's role in shaping imagination and creativity. Water provides endless opportunities for recreation. Swimming, boating, fishing, and surfing are popular activities that bring people together. Lakes, rivers, and oceans offer spaces for relaxation and adventure. Recreational use of water supports health, happiness, and community. Wildlife depends on water for survival. Fish, birds, amphibians, and mammals all need water for drinking, breeding, and feeding. Wetlands and rivers are critical habitats for many species. Protecting water sources helps preserve biodiversity and maintain healthy ecosystems. Water availability influences migration patterns for both humans and animals. People move to areas with reliable water sources, while animals follow rivers and lakes during seasonal migrations. Water scarcity can drive displacement and conflict, highlighting its importance for stability. Competition for water has led to conflict throughout history. Disputes over rivers, lakes, and aquifers can escalate into wars or political tensions. Cooperation and fair management are essential for preventing conflict and ensuring peace. Innovative solutions are emerging to address water challenges. Technologies like desalination, water recycling, and smart irrigation help conserve and manage water. Research and development drive progress, ensuring that water remains available for all. Sustainable water management is crucial for the future. Balancing human needs with environmental protection requires careful planning and cooperation. Sustainable practices include conserving water, protecting sources, and restoring ecosystems. Climate change affects water availability and quality. Melting glaciers, changing rainfall patterns, and rising sea levels threaten water resources. Adaptation and mitigation strategies are needed to protect water and ensure resilience. Water-related disasters like floods, droughts, and hurricanes impact millions of people. These events disrupt communities, damage infrastructure, and threaten lives. Disaster preparedness and response are vital for minimizing harm and supporting recovery. Infrastructure is essential for managing water. Dams, reservoirs, pipelines, and treatment plants ensure reliable supply and quality. Investment in infrastructure supports economic development and public health. Policies guide water management and distribution. Governments set regulations to protect water sources, ensure fair access, and promote conservation. Effective policies balance human needs with environmental sustainability. Education empowers people to protect water resources. Schools teach the importance of water conservation, pollution prevention, and sustainable use. Community programs raise awareness and inspire action. Scientific research advances our understanding of water. Studies explore water's properties, its role in ecosystems, and ways to improve management. Innovation in science leads to new solutions for water challenges. The future holds many challenges for water. Population growth, climate change, and pollution threaten supplies. Preparing for these challenges requires global cooperation, innovation, and commitment to sustainability. Global cooperation is essential for managing water resources. International agreements help share rivers, lakes, and aquifers across borders. Collaboration ensures fair access and protects water for all. Technological innovation is transforming water management. Smart sensors, data analytics, and automated systems improve efficiency and reduce waste. Technology helps monitor water quality and predict shortages. Social equity is a key issue in water management. Access to clean water varies by region, income, and gender. Ensuring fair distribution supports health, education, and economic opportunity for all. Urban planning integrates water management into city design. Green spaces, stormwater systems, and sustainable infrastructure help cities adapt to changing water needs. Planning ensures resilience and quality of life. Agricultural innovation improves water use. Drip irrigation, drought-resistant crops, and precision farming reduce waste and increase yields. Technology supports sustainable food production and resource conservation. Biodiversity depends on water. Rivers, lakes, and wetlands support diverse species and complex ecosystems. Protecting water sources preserves biodiversity and ensures ecosystem resilience. Access to clean water is a human right. International organizations advocate for universal access, recognizing water's importance for health, dignity, and development. Protecting this right is essential for justice and equality. Future solutions for water challenges include new technologies, policies, and community action. Investing in research, education, and infrastructure will help secure water for generations to come. Collaboration and innovation are key to overcoming obstacles. Global awareness of water issues is growing. Media, education, and activism highlight the importance of water and inspire action. Raising awareness helps drive change and protect resources. Communities play a vital role in protecting water. Local initiatives restore rivers, clean lakes, and promote conservation. Community action builds resilience and ensures sustainable water management. Water has shaped life and civilization in countless ways. Its unique properties support biological processes, ecosystems, and human societies. From ancient rivers to modern cities, water remains central to our existence. Protecting and managing water is essential for a sustainable future. As we reflect on water's legacy, let's remember its power to connect, sustain, and inspire life on Earth. Welcome to our exploration of Earth's most powerful natural events: earthquakes, volcanoes, and storms. These phenomena shape our planet, impact lives, and remind us of nature's immense power. Today, we'll dive into how these events occur, what causes them, and their effects on the world around us. From the trembling ground beneath our feet to fiery eruptions and raging storms, understanding these forces is crucial for appreciating the dynamic planet we call home. Let's begin our journey by setting the stage for what makes Earth so active and unpredictable. The Earth's crust is not a solid, unchanging shell. Instead, it's made up of massive plates that float atop a layer of molten rock called the mantle. These plates, known as tectonic plates, are constantly moving, albeit very slowly. Their movement is responsible for many of the planet's most dramatic events. When plates collide, pull apart, or slide past each other, they create stresses that can lead to earthquakes and volcanic eruptions. This dynamic system is the foundation for understanding why Earth is so geologically active. Earthquakes are sudden, violent shaking of the ground caused by the movement of tectonic plates. When plates grind against each other, or collide, stress builds up until it's released in a burst of energy. This energy travels as seismic waves, shaking the ground and sometimes causing significant destruction. Earthquakes can happen anywhere tectonic plates meet, but some regions are more prone due to their location along plate boundaries. Understanding earthquakes helps us prepare for and respond to these unpredictable events. When an earthquake occurs, energy radiates outward from the epicenter in the form of seismic waves. These waves travel through the Earth, shaking everything in their path. There are different types of seismic waves: primary waves, P waves, secondary waves, S waves, and surface waves. P waves are the fastest and move through both solid and liquid layers, while S waves are slower and only travel through solids. Surface waves cause the most damage as they move along the Earth's surface. The epicenter is the point on the Earth's surface directly above where an earthquake originates, called the focus or hypocenter. The focus is deep underground, where tectonic plates slip or fracture. The closer the epicenter is to populated areas, the greater the potential for damage. Scientists use seismographs to pinpoint the epicenter and measure the strength of earthquakes, helping communities respond quickly and effectively. Earthquakes are measured using the Richter scale and the moment magnitude scale. The Richter scale quantifies the energy released, while the moment magnitude scale provides a more accurate measure of the earthquake's size. Seismographs record the intensity and duration of seismic waves, allowing scientists to determine the magnitude and impact. Understanding these measurements helps us assess risks and improve safety in earthquake-prone regions. Earthquakes can cause widespread destruction, including collapsed buildings, damaged infrastructure, and landslides. They may also trigger tsunamis if the quake occurs under the ocean. The severity of effects depends on the earthquake's magnitude, depth, and proximity to populated areas. Emergency preparedness and building codes are essential for minimizing damage and saving lives during these unpredictable events. Volcanoes are openings in the Earth's crust where molten rock, ash, and gases escape from beneath the surface. They form at tectonic plate boundaries, especially where plates collide or move apart. When pressure builds up in the magma chamber, it forces magma upward, resulting in an eruption. Volcanoes can be explosive or gentle, depending on the type of magma and the geological setting. Volcanoes come in several shapes and sizes. Shield volcanoes have gentle slopes and produce slow, steady lava flows. Stratovolcanoes, or composite volcanoes, are tall and steep, often erupting explosively. Cinder cone volcanoes are small and form from ash and debris. Each type has unique eruption patterns and hazards, making it important to understand their differences for safety and scientific study. Volcanic eruptions occur when magma rises through cracks in the Earth's crust, reaching the surface. The eruption can be explosive, sending ash and gases high into the atmosphere, or effusive, with lava flowing gently down the volcano's sides. The type of eruption depends on the magma's composition and the pressure inside the volcano. Eruptions can reshape landscapes and affect global climate. Volcanoes can cause widespread destruction, including lava flows, ash clouds, and pyroclastic flows. Ash can cover large areas, disrupt air travel, and damage crops. Pyroclastic flows are fast-moving, hot clouds of gas and debris that can devastate everything in their path. Despite their dangers, volcanoes also create fertile soils and new land, contributing to Earth's ongoing transformation. The Ring of Fire is a region around the Pacific Ocean where many earthquakes and volcanoes occur. It's one of the most geologically active areas on Earth, with frequent eruptions and seismic activity. The Ring of Fire is caused by the movement of several tectonic plates, making it a hotspot for natural disasters. Understanding this region helps scientists predict and prepare for future events. Not all volcanoes are at plate boundaries. Some form at hotspots, where magma rises from deep within the mantle. Supervolcanoes are rare but extremely powerful, capable of causing global climate changes. Yellowstone is a famous example of a supervolcano. Studying hotspots and supervolcanoes helps us understand Earth's internal processes and the potential for catastrophic eruptions. Storms are powerful atmospheric events caused by changes in air pressure, temperature, and moisture. They range from thunderstorms to hurricanes, each with unique characteristics and hazards. Storms can bring heavy rain, strong winds, lightning, and flooding. Understanding how storms form and behave is essential for predicting weather and staying safe during extreme conditions. Thunderstorms are common storms characterized by lightning, thunder, heavy rain, and sometimes hail. They form when warm, moist air rises and cools, creating clouds and precipitation. Lightning is caused by electrical charges within the storm, while thunder is the sound of lightning's rapid heating of air. Thunderstorms can lead to flash floods and dangerous conditions. Hurricanes and typhoons are massive storms that form over warm ocean waters. They are known for their powerful winds, heavy rain, and storm surges. These storms are called hurricanes in the Atlantic and typhoons in the Pacific. They can cause widespread destruction, flooding, and loss of life. Early warning systems and evacuation plans are crucial for minimizing their impact. Tornadoes are violent, rotating columns of air that extend from thunderstorms to the ground. They are among the most destructive storms, capable of tearing through buildings and uprooting trees. Tornadoes form when warm, moist air meets cold, dry air, creating instability. Their unpredictable nature makes them especially dangerous, requiring quick response and shelter. Storms can cause flooding, property damage, power outages, and loss of life. The severity depends on the storm's strength, duration, and location. Floods are common during storms, especially in low-lying areas. Strong winds can topple trees and power lines, while lightning poses risks to people and animals. Preparedness and early warnings are key to reducing storm impacts. Weather forecasting uses technology and science to predict storms and other atmospheric events. Meteorologists analyze data from satellites, radar, and weather stations to provide accurate forecasts. Early warnings help communities prepare for storms, reducing risks and saving lives. Advances in forecasting continue to improve our ability to anticipate and respond to extreme weather. Climate influences the frequency and intensity of storms. Warmer temperatures can lead to stronger hurricanes and more frequent thunderstorms. Climate change is increasing the risk of extreme weather events worldwide. Understanding the relationship between climate and storms helps us adapt and prepare for future challenges. Safety during earthquakes involves preparedness and quick action. Secure heavy objects, create emergency kits, and know safe spots in your home. During an earthquake, drop, cover, and hold on to protect yourself from falling debris. After the shaking stops, check for injuries and hazards. Community drills and education help everyone stay safe. Volcano safety includes monitoring alerts, evacuation plans, and protective measures. Stay informed about volcanic activity in your area. If an eruption occurs, follow evacuation orders and avoid areas downwind of ash clouds. Protective masks and goggles help shield against ash and gases. Education and preparedness are vital for minimizing risks during volcanic events. Storm safety involves staying informed, preparing emergency supplies, and knowing evacuation routes. Listen to weather forecasts and warnings. Secure outdoor items, close windows, and seek shelter during severe storms. Avoid flooded areas and stay indoors during lightning. Community preparedness and early warnings are essential for reducing storm-related injuries and damage. Tectonic plates move due to convection currents in the mantle. These currents are caused by heat from Earth's core, creating a cycle of rising and sinking material. Plate movement is slow but powerful, shaping continents and causing earthquakes and volcanoes. Understanding plate tectonics is key to predicting and explaining many natural disasters. There are three main types of plate boundaries: divergent, convergent, and transform. Divergent boundaries occur where plates move apart, forming new crust. Convergent boundaries happen where plates collide, creating mountains or subduction zones. Transform boundaries are where plates slide past each other, often causing earthquakes. Each boundary type has unique geological features and risks. Let's visualize how an earthquake happens. Imagine two tectonic plates locked together along a fault line. Over time, stress builds as the plates try to move. Eventually, the stress is released, causing the plates to slip and sending seismic waves outward. This sudden movement is what we feel as an earthquake. The schematic shows the fault line, plates, and the direction of movement, helping us understand the mechanics behind these powerful events. To understand volcanoes, let's look at a cross-section of a typical volcano. Magma rises from the mantle through a chamber beneath the volcano. When pressure builds, magma escapes through the vent, erupting as lava, ash, and gases. The schematic illustrates the magma chamber, main vent, and layers of the volcano, showing how eruptions occur and reshape the landscape. Storms form when warm, moist air rises and cools, creating clouds and precipitation. The schematic shows the movement of air, formation of clouds, and development of lightning. Arrows indicate rising air and condensation, while symbols represent rain and thunder. This visualization helps explain the basic mechanics behind thunderstorms and other storm types. The core concept behind earthquakes is the movement of tectonic plates and the release of built-up stress. When plates shift suddenly, energy is released as seismic waves, causing the ground to shake. This process is fundamental to understanding why earthquakes occur and how they impact the planet. Volcanoes are driven by the movement of magma from Earth's mantle to the surface. The buildup of pressure in the magma chamber leads to eruptions, releasing lava, ash, and gases. This concept explains the formation and activity of volcanoes, highlighting their role in shaping landscapes and creating new land. Storms are caused by atmospheric instability, where warm, moist air rises and interacts with cooler air. This process leads to cloud formation, precipitation, and sometimes severe weather, like lightning and tornadoes. Understanding this concept is key to predicting and preparing for storms. Let's examine a real-world earthquake. The 2011 Tohoku earthquake in Japan was a magnitude 9 event, causing massive destruction and triggering a tsunami. The quake occurred along a subduction zone, where one plate slid beneath another. This case highlights the importance of preparedness and the devastating power of earthquakes. Mount St. Helens erupted in 1980, demonstrating the explosive power of volcanoes. The eruption was triggered by a massive landslide and released ash, lava, and gases. The event reshaped the landscape and provided valuable scientific insights into volcanic activity and hazards. Hurricane Katrina struck the United States in 2005, causing widespread flooding and destruction. The storm's powerful winds and storm surge overwhelmed levees, leading to catastrophic damage. This case underscores the importance of forecasting, preparedness, and resilient infrastructure. Predicting earthquakes is challenging due to their sudden nature. Scientists study seismic activity, fault lines, and historical data to identify risk areas. While exact predictions are rare, ongoing research improves our understanding and helps communities prepare for future events. Volcanoes are monitored using sensors, satellites, and ground observations. Scientists track changes in gas emissions, ground deformation, and seismic activity to predict eruptions. Early warnings help communities evacuate and reduce risks during volcanic events. Storms are tracked using radar, satellites, and weather stations. Meteorologists monitor storm development, movement, and intensity to provide timely warnings. Tracking helps communities prepare and respond to severe weather, minimizing damage and saving lives. Human activities can influence natural disasters. Building in high-risk areas, deforestation, and climate change increase vulnerability to earthquakes, volcanoes, and storms. Sustainable practices and resilient infrastructure help reduce risks and protect communities. Recovery after disasters involves rebuilding, providing aid, and restoring services. Communities work together to repair damage, support affected people, and improve preparedness for future events. Recovery is a long process, but it strengthens resilience and unity. Preparedness for natural disasters is a global effort. Countries share knowledge, technology, and resources to improve safety and response. International cooperation helps predict, monitor, and recover from earthquakes, volcanoes, and storms, protecting lives worldwide. Technology plays a vital role in disaster management. Early warning systems, communication networks, and data analysis help predict and respond to natural disasters. Innovations like drones and AI improve monitoring and recovery, making disaster management more effective. Education and awareness are key to reducing disaster risks. Teaching people about earthquakes, volcanoes, and storms helps them prepare and respond effectively. Schools, communities, and governments promote safety through drills, information campaigns, and training. Building resilience and adapting to natural disasters is essential for communities. Strengthening infrastructure, improving emergency plans, and fostering community support help withstand and recover from earthquakes, volcanoes, and storms. Adaptation ensures long-term safety and sustainability. As our planet changes, new challenges arise in managing natural disasters. Climate change, population growth, and urbanization increase risks and complexity. Ongoing research, innovation, and cooperation are needed to address these challenges and protect people worldwide. Earthquakes, volcanoes, and storms are powerful reminders of nature's force and unpredictability. By understanding how these events happen, preparing for their impacts, and working together, we can build safer, more resilient communities. Living with nature means respecting its power and adapting to its challenges, ensuring a brighter future for all. Welcome to our exploration of mass extinctions, those dramatic events that reshaped life on Earth. Throughout history, our planet has witnessed several mass extinctions, each wiping out vast numbers of species and altering the course of evolution. Today, we'll uncover what caused these catastrophic events and how life managed to bounce back. From asteroid impacts to volcanic eruptions and climate shifts, the story of extinction is both tragic and fascinating. Let's begin by understanding what a mass extinction is and why it matters for the history of life. A mass extinction is defined as a period when Earth loses a significant proportion of its species in a relatively short geological timeframe. Typically, these events see at least 75% of species disappear. The causes are often abrupt and global, making recovery a monumental challenge. Understanding mass extinctions helps us appreciate the resilience of life and the fragility of ecosystems. Let's look at the criteria scientists use to identify these events and why they stand out from regular extinctions. Earth has experienced 5 major mass extinctions, each marking a turning point in the history of life. These include the Ordovician, Silurian, Devonian, Permian, Triassic, and Cretaceous extinctions. Each event was triggered by unique environmental changes yet all led to widespread loss of biodiversity. By studying these events, scientists gain insight into the patterns of extinction and recovery, helping us understand how life adapts to extreme challenges. The first major mass extinction occurred around 443 million years ago, at the boundary of the Ordovician and Silurian periods. It wiped out nearly 85% of marine species, making it one of the most severe events. Scientists believe that dramatic climate changes, including glaciation and sea level drops, were the primary causes. These shifts disrupted marine habitats, leading to widespread extinction. Let's explore how these environmental changes unfolded. The Devonian extinction, about 375 million years ago, was a prolonged event that affected mainly marine life. Over several million years, nearly 75% of species vanished. The causes are debated, but factors like ocean, anoxia, climate fluctuations, and possibly asteroid impacts played roles. This extinction paved the way for new groups of organisms to emerge, reshaping the marine ecosystem. Let's dive into the possible triggers and consequences. The Permian extinction, also known as the Great Dying, occurred about 252 million years ago and is the most severe mass extinction in Earth's history. Around 96% of marine species and 70% of terrestrial species disappeared. Massive volcanic eruptions in Siberia released enormous amounts of greenhouse gases, causing rapid climate change, ocean acidification, and widespread habitat loss. This event dramatically altered the course of evolution. The Triassic extinction happened around 201 million years ago, clearing the way for dinosaurs to dominate. About 80% of species were lost, including many marine reptiles and large amphibians. The causes likely include volcanic activity, climate change, and possibly asteroid impacts. This extinction set the stage for the rise of new life forms, including the first true mammals and dinosaurs. The Cretaceous extinction, about 66 million years ago, is famous for ending the reign of the dinosaurs. An asteroid impact in what is now Mexico triggered fires, climate shifts, and blocked sunlight, leading to the extinction of nearly 75% of species. This event opened ecological niches for mammals and birds, eventually leading to the rise of humans. Let's examine the evidence for this dramatic event. Scientists have found strong evidence for the asteroid impact that caused the Cretaceous extinction. The Chicxulub crater in Mexico, along with layers of iridium-rich clay found worldwide, points to a massive collision. This impact released energy equivalent to billions of atomic bombs, causing fires, tsunamis, and a nuclear winter effect. The aftermath led to rapid environmental changes and mass extinction. Volcanic eruptions have been linked to several mass extinctions, especially the Permian and Triassic events. Massive eruptions release greenhouse gases, ash, and toxic chemicals, altering climate and ocean chemistry. These changes can lead to acid rain, ocean acidification, and widespread habitat destruction. Volcanic activity is a powerful force in shaping Earth's history and influencing the survival of species. Climate change is a recurring theme in mass extinctions. Rapid shifts in temperature, precipitation, and ocean currents can disrupt ecosystems and food chains. Glaciation, warming, and changes in sea level have all played roles in past extinctions. These environmental stresses make it difficult for species to adapt, leading to widespread loss. Understanding these effects helps us recognize the importance of stable climates for life. Ocean anoxia, or the loss of oxygen in seawater, is another major cause of extinction. When oceans become depleted of oxygen, marine life struggles to survive. This condition can result from climate change, volcanic activity, or changes in ocean circulation. Ocean anoxia played a significant role in the Devonian and Permian extinctions, wiping out many marine species and altering the balance of life. Changes in sea level have profound effects on marine and coastal ecosystems. During mass extinctions, sea levels often dropped or rose rapidly, exposing or flooding habitats. These shifts can lead to habitat loss, changes in salinity, and altered migration patterns. Sea level changes contributed to the Ordovician-Silurian extinction and others, highlighting the interconnectedness of Earth's systems. Volcanic eruptions and asteroid impacts can release toxic chemicals into the atmosphere and oceans. These substances, such as sulfur dioxide and heavy metals, can poison ecosystems and disrupt food chains. Toxic fallout from these events often leads to acid rain, ocean acidification, and widespread mortality. The role of toxins in mass extinctions underscores the vulnerability of life to environmental contamination. When a large asteroid strikes Earth, the impact releases immense energy, vaporizing rock, and creating shock waves. Debris is thrown into the atmosphere, blocking sunlight and cooling the planet. Fires, tsunamis, and acid rain follow, causing rapid environmental changes. The mechanics of asteroid impacts explain why these events are so devastating and why recovery is so difficult. Volcanic eruptions can cover vast areas with lava and ash, releasing greenhouse gases and toxic chemicals. The eruption column rises into the atmosphere, spreading ash and gases globally. These changes can cool or warm the planet, depending on the balance of gases. The mechanics of volcanic eruptions illustrate how a single event can have worldwide consequences for climate and life. Climate change during mass extinctions often results from greenhouse gas buildup, volcanic eruptions, or asteroid impacts. These mechanisms alter atmospheric composition, leading to temperature shifts and changes in precipitation. Ocean currents and wind patterns are affected, disrupting ecosystems. The interplay of these factors explains the complexity of climate-driven extinctions. Ocean anoxia occurs when oxygen levels drop, often due to climate change or volcanic activity. This leads to dead zones, where marine life cannot survive. The mechanisms involve changes in ocean circulation, increased nutrient runoff, and warming waters. Understanding these processes helps explain why marine extinctions are so common during mass extinction events. Rapid sea level changes can flood or expose habitats, leading to extinction. Mechanisms include glaciation, melting ice, and tectonic shifts. These changes alter coastal and marine environments, affecting migration and breeding. Sea level fluctuations are a key driver in several mass extinctions, showing how interconnected Earth systems are. Toxic fallout from volcanic eruptions and asteroid impacts spreads chemicals globally. Mechanisms include atmospheric circulation, rainout, and ocean deposition. These toxins poison ecosystems, leading to rapid mortality and extinction. Understanding toxic fallout helps explain the widespread impact of mass extinction events. After a mass extinction, ecosystems are left devastated. Survivors face harsh conditions, including altered climates, scarce resources, and new predators. The immediate aftermath is marked by instability and slow recovery. Species that can adapt quickly have a better chance of survival, while others perish. This period sets the stage for evolutionary innovation. Not all life perishes during mass extinctions. Certain species, often small, adaptable, or widespread, manage to survive. These survivors become the ancestors of new groups, driving evolutionary change. Examples include mammals after the Cretaceous extinction and reptiles after the Permian event. Studying survivor species reveals the traits that enable resilience. Mass extinctions clear ecological niches, allowing surviving species to diversify and evolve. With fewer competitors and predators, new forms of life emerge. This process, known as adaptive radiation, leads to rapid speciation and innovation. The recovery of life is shaped by the opportunities created by extinction. The aftermath of extinction often sparks evolutionary innovation. New traits, behaviors, and body plans appear as species adapt to changing environments. Examples include the rise of mammals, birds, and flowering plants after the Cretaceous extinction. Innovation drives the recovery and diversification of life, shaping future ecosystems. Adaptive radiation is the rapid diversification of species into new niches. After mass extinctions, surviving groups evolve quickly to fill empty roles. This process leads to bursts of speciation and the emergence of novel forms. Adaptive radiation is a key mechanism in the recovery of life and the creation of biodiversity. Recovery from mass extinction is slow, often taking millions of years. Ecosystems gradually rebuild as new species evolve and diversify. The timeline depends on the severity of extinction and environmental conditions. Fossil records show that recovery can be uneven, with some groups rebounding faster than others. Understanding recovery timelines helps us appreciate the resilience of life. After the Permian extinction, life took nearly 10 million years to recover. Early survivors included small reptiles, amphibians, and marine invertebrates. Gradually, new groups like dinosaurs and mammals emerged, reshaping terrestrial and marine ecosystems. The Permian recovery illustrates the challenges and opportunities following the most severe extinction event. The recovery after the Cretaceous extinction saw mammals and birds diversify rapidly. With dinosaurs gone, mammals evolved into new forms, eventually leading to primates and humans. Birds also flourished, filling ecological roles left vacant. The Cretaceous recovery highlights the power of adaptive radiation and evolutionary innovation. Marine ecosystems also recover after mass extinctions, though often more slowly. New groups of fish, mollusks, and corals emerge, rebuilding food webs and habitats. Recovery is influenced by ocean chemistry, climate, and available niches. Marine recovery demonstrates the interconnectedness of life and the importance of environmental stability. On land, recovery involves the evolution of new plants, animals, and ecosystems. Forests, grasslands, and deserts develop as species adapt to changing climates. Terrestrial recovery is shaped by competition, predation, and environmental factors. The rise of flowering plants and mammals after the Cretaceous extinction transformed Earth's landscapes. Mutations play a crucial role in recovery and adaptation. Genetic changes create new traits, some of which help species survive in altered environments. Over time, beneficial mutations spread through populations, driving evolution. The role of mutation highlights the importance of genetic diversity in the resilience of life. Natural selection shapes the recovery of life after extinction. Species with advantageous traits survive and reproduce, while others perish. This process leads to the emergence of new forms and the adaptation of survivors. Natural selection is the engine of evolution, driving the diversification and resilience of life. Speciation is the formation of new species, often accelerated after mass extinctions. As survivors adapt to new niches, reproductive barriers arise, leading to the creation of distinct groups. Speciation drives biodiversity and shapes the recovery of ecosystems. The fossil record reveals bursts of speciation following extinction events. Ecosystem rebuilding is a gradual process after mass extinction. New food webs, habitats, and interactions develop as species diversify. Recovery depends on environmental stability and the availability of resources. Ecosystem rebuilding is essential for the restoration of biodiversity and the resilience of life. Plants play a vital role in recovery, stabilizing soils, producing oxygen, and forming the basis of food webs. After mass extinctions, new plant groups often emerge, adapting to altered climates and environments. The rise of flowering plants after the Cretaceous extinction transformed terrestrial ecosystems, supporting the diversification of animals. Microbes are often the first to recover after mass extinctions. They play key roles in nutrient cycling, decomposition, and ecosystem stability. Microbial innovation can drive the recovery of larger organisms, supporting the rebuilding of food webs. The resilience of microbes highlights their importance in the survival and recovery of life. Climate plays a central role in the recovery of life. Stable climates support the rebuilding of ecosystems, while ongoing instability slows recovery. Climate influences the distribution of species, the development of habitats, and the pace of evolution. Understanding the role of climate helps explain the patterns of recovery after mass extinction. Geography influences recovery by shaping the distribution of survivors and the development of new ecosystems. Isolated regions can foster unique evolutionary paths, while connected areas support rapid diversification. Geographic barriers and corridors play key roles in speciation and adaptation. The role of geography underscores the complexity of recovery. Competition among survivors drives adaptation and innovation. As species vie for resources and niches, new traits and behaviors emerge. Competition shapes the structure of ecosystems and the pace of recovery. The role of competition highlights the dynamic nature of post-extinction environments. Predation shapes recovery by influencing population dynamics and evolutionary pressures. New predators can drive the adaptation of prey, leading to evolutionary arms races. Predation helps regulate ecosystems and supports the diversification of life. The role of predation is essential in understanding post-extinction recovery. Symbiotic relationships, such as mutualism and commensalism, support recovery by fostering cooperation and resource sharing. These interactions help stabilize ecosystems and promote biodiversity. Symbiosis is a key factor in the resilience of life after mass extinction, enabling species to thrive in challenging environments. Today, human activities are driving a new wave of extinctions. Habitat destruction, pollution, climate change, and overexploitation threaten biodiversity. Scientists warn that we may be entering a sixth mass extinction, with consequences for ecosystems and humanity. Understanding past extinctions helps us recognize the urgency of conservation. The history of mass extinctions teaches us about the resilience and vulnerability of life. Recovery is possible, but it takes time and depends on environmental stability. By learning from the past, we can make informed decisions to protect biodiversity and support the recovery of ecosystems. The lessons of extinction are vital for our future. Despite the challenges, life has shown remarkable resilience after mass extinctions. Recovery is driven by adaptation, innovation, and cooperation. By protecting habitats, reducing pollution, and supporting conservation, we can help ensure the survival and recovery of life. Hope for recovery is grounded in the lessons of history and the power of nature. In conclusion, mass extinctions are pivotal events in Earth's history, reshaping life and driving evolution. The causes range from asteroid impacts to volcanic eruptions and climate change. Recovery is slow but possible, fueled by adaptation and innovation. By understanding these events, we gain insight into the resilience of life and the importance of protecting our planet. Thank you for joining us on this journey through extinction and recovery. Energy has always been at the heart of human progress. From the earliest days, our ancestors sought ways to harness natural forces to improve their lives. This journey began with fire, a discovery that transformed survival and paved the way for civilization. As we move through history, we'll see how each new form of energy reshaped society, technology, and daily life. Today, we'll explore the fascinating story of how energy evolved, from the flickering flames of ancient hearths to the bright lights powered by electricity. Let's embark on this journey to understand how energy has changed the course of human life. The discovery of fire marked a turning point in human history. Early humans learned to control fire, using it for warmth, protection, and cooking. This ability allowed them to survive in harsh climates, extend their days, and improve their diets. Fire also fostered social gatherings, as people came together around the flames to share stories and food. The mastery of fire was more than just a technological leap. It was a cultural revolution that set the stage for future innovations. As we look back, it's clear that fire was the first step in humanity's quest to harness energy. With fire, humans could cook food, making it safer and more nutritious. This led to better health and longer lifespans. Fire also enabled people to settle in colder regions, expanding their reach across the globe. It became a tool for crafting, allowing the creation of pottery, tools, and weapons. The ability to manipulate fire was a foundation for early industries and crafts. Communities grew around shared hearths, and the use of fire became central to rituals and traditions. The influence of fire on society was profound, shaping the way humans lived, worked, and interacted. Beyond fire, early humans began to harness other energy sources. The sun provided warmth and light, while wind and water powered simple machines like mills and boats. These natural forces were essential for agriculture, transportation, and daily life. By observing and utilizing their environment, humans laid the groundwork for more complex energy systems. The use of wind and water marked the beginning of mechanical energy, setting the stage for future technological advances. These early sources were limited but vital, helping societies grow and thrive. As civilizations advanced, water and wind became crucial energy sources. Water wheels powered mills, grinding grain, and pumping water. Windmills harnessed the breeze to perform similar tasks. These innovations allowed communities to process food and manage resources more efficiently. The use of water and wind power was a major step forward, enabling larger settlements and supporting economic growth. These technologies demonstrated the potential of renewable energy long before the modern era. The legacy of water and wind power can still be seen in today's sustainable energy solutions. With the development of agriculture, energy needs shifted. Farming required new tools and methods, often powered by human and animal labor. The domestication of animals provided a reliable source of energy for plowing fields and transporting goods. This shift allowed societies to produce surplus food, leading to population growth and urbanization. Energy from animals and manual labor was the backbone of early agricultural economies. The rise of agriculture marked a new chapter in the story of energy, as humans learned to harness biological power for their benefit. Animals played a vital role in early energy systems. Horses, oxen, and donkeys were used for plowing, transportation, and carrying heavy loads. This reliance on animal power made farming and trade more efficient, enabling larger communities and more complex economies. Animal energy was renewable and sustainable, as long as the animals were cared for. The use of animal power was a key factor in the growth of civilizations, providing the muscle needed for construction, agriculture, and commerce. Even today, animal power remains important in some parts of the world. Ancient civilizations developed sophisticated ways to use energy. The Egyptians built irrigation systems powered by the Nile, while the Greeks and Romans constructed aqueducts and used water wheels. These innovations supported large populations and complex societies. Energy was also used in construction, with massive monuments and temples built using human and animal labor. The ability to harness energy allowed ancient civilizations to flourish, creating lasting legacies in architecture, engineering, and culture. Their achievements laid the foundation for future energy advancements. As cities grew, energy needs increased. Urban centers required more food, water, and transportation. Energy was essential for building infrastructure, from roads and bridges to public baths and markets. The concentration of people in cities drove innovation, as new solutions were needed to meet the demands of urban life. The development of energy systems supported trade, communication, and governance. Urban growth was closely tied to advances in energy, shaping the way societies organized and interacted. The story of cities is also the story of energy. Wood became a primary energy source for many societies. It was used for heating, cooking, and building materials. Forests provided a renewable supply, but overuse led to shortages and environmental challenges. The reliance on wood-shaped settlement patterns, as communities often formed near forests. Wood fueled industries like pottery, metalworking, and shipbuilding. Its importance lasted for centuries, until new energy sources emerged. The story of wood highlights the balance between resource use and sustainability, a lesson still relevant today. Charcoal, made from wood, became an important fuel for early industries. It burned hotter than wood, making it ideal for metalworking and glass production. Charcoal was used to smelt iron and create tools, weapons, and structures. The rise of charcoal-powered industries marked a shift from simple crafts to large-scale manufacturing. This transition laid the groundwork for the Industrial Revolution as societies sought more efficient ways to produce goods. Charcoal's role in early industry was a key step in the evolution of energy use. The discovery and use of coal transformed energy systems. Coal provided a powerful, concentrated source of energy, fueling steam, engines, and factories. The Industrial Revolution was driven by coal, enabling mass production, transportation, and urbanization. Coal-powered trains and ships connected distant regions, while factories produced goods at unprecedented scales. The shift to coal marked a new era of energy with profound impacts on society, economy, and the environment. The legacy of coal is still visible in modern industry and infrastructure. Steam power revolutionized technology and industry. Steam engines converted coal into mechanical energy, driving machines and vehicles. Factories became more efficient, producing textiles, tools, and goods at a rapid pace. Steam locomotives and ships made transportation faster and more reliable. The use of steam power marked a shift from manual labor to mechanized systems, changing the nature of work and society. Steam engines were the backbone of the Industrial Revolution, setting the stage for future energy innovations. The rise of industrial energy sources fueled rapid urbanization. Cities grew as people moved to work in factories and industries. Energy was needed for lighting, heating, and transportation, shaping the design and function of urban spaces. The concentration of industry and population led to new challenges, including pollution and resource management. Urbanization was both a result and a driver of energy innovation, as cities became centers of progress and change. The relationship between energy and urban growth continues to shape modern life. Oil became a dominant energy source in the 20th century. It powered cars, airplanes, and factories, driving economic growth and globalization. Oil was used to produce fuels, plastics, and chemicals, transforming industries and daily life. The discovery of oil fields and the development of refineries enabled large-scale production and distribution. Oil's versatility and efficiency made it the backbone of modern economies. However, reliance on oil also brought environmental challenges and geopolitical tensions, highlighting the need for sustainable energy solutions. The discovery and harnessing of electricity marked a new era in energy. Early experiments with static electricity and batteries led to the development of generators and power grids. Electricity provided a clean, efficient, and versatile source of energy, powering homes, businesses, and industries. The ability to transmit energy over long distances revolutionized society, enabling new technologies and conveniences. The emergence of electricity changed the way people lived, worked, and interacted, ushering in the modern age. Electric lighting transformed daily life. The invention of the light bulb made it possible to illuminate homes, streets, and workplaces safely and efficiently. Electric lights replaced candles and gas lamps, reducing fire hazards and improving visibility. This innovation extended productive hours, supported urban growth, and enhanced quality of life. Electric lighting was a symbol of progress, marking the transition to a new era of energy use. Today, electric lights are everywhere, a testament to the power of electricity. Electricity brought new conveniences to homes. Appliances like refrigerators, washing machines, and radios made daily tasks easier and more enjoyable. Electric heating and cooling improved comfort, while electric stoves and ovens revolutionized cooking. The spread of electric power changed the way families lived, creating new routines and opportunities. Electricity enabled access to information, entertainment, and communication, connecting people in ways never before possible. The impact of electric power on home life was profound and lasting. Electricity enabled new forms of communication. The telegraph and telephone allowed people to connect across great distances, transforming business and personal relationships. Radio and television brought news, entertainment, and education into homes, shaping culture and society. The development of electronic communication was a major milestone, making the world more interconnected and informed. Electricity continues to drive advances in communication, from the internet to mobile devices, changing the way people interact and share information. Electricity revolutionized transportation. Electric trains, trams, and subways made travel faster, cleaner, and more efficient. Electric vehicles are now transforming roads, reducing pollution and dependence on fossil fuels. The use of electric power in transportation supports sustainable development and urban mobility. Innovations in battery technology and charging infrastructure are making electric transportation more accessible and practical. The shift to electric vehicles is a key part of the ongoing energy transition. Modern industries rely on diverse energy sources. Electricity powers factories, computers, and communication networks. Oil and gas, fuel, transportation, and manufacturing, while renewable energy is becoming increasingly important. The integration of energy systems supports economic growth, innovation, and sustainability. Industries are constantly seeking new ways to improve efficiency and reduce environmental impact. The evolution of energy continues to drive progress, shaping the future of work and society. Renewable energy is changing the way we power our world. Solar, wind, and hydroelectric energy provide clean, sustainable alternatives to fossil fuels. These sources are abundant and environmentally friendly, reducing pollution and greenhouse gas emissions. The adoption of renewable energy is driven by technological advances and a growing awareness of environmental issues. Renewable energy is becoming more affordable and accessible, supporting the transition to a sustainable future. The shift to renewables is a major milestone in the history of energy. Solar power is one of the fastest-growing energy sources. Photovoltaic panels convert sunlight into electricity, providing clean energy for homes, businesses, and industries. Solar power is scalable, from small rooftop installations to large solar farms. Advances in technology have made solar energy more efficient and affordable. The use of solar power reduces reliance on fossil fuels and supports environmental sustainability. The solar revolution is transforming the energy landscape, offering new opportunities for innovation and growth. Wind energy is another key renewable resource. Modern wind turbines capture the power of the wind, converting it into electricity. Wind farms are being built around the world, providing clean energy for communities and industries. Advances in turbine design and grid integration have made wind energy more reliable and cost-effective. Wind power reduces carbon emissions and supports sustainable development. The growth of wind energy is a testament to human ingenuity and the ongoing evolution of energy. Hydroelectric power uses the energy of moving water to generate electricity. Dams and turbines convert river flow into mechanical and electrical energy. Hydroelectric plants provide reliable, renewable power for millions of people. This technology has been used for decades, supporting economic development and environmental sustainability. Hydroelectric power is a cornerstone of renewable energy, demonstrating the potential of natural forces to meet human needs. Its role in the energy mix continues to grow as we seek cleaner alternatives. Nuclear energy offers a powerful and efficient source of electricity. Nuclear reactors use controlled reactions to generate heat, which is converted into electrical power. Nuclear energy produces minimal greenhouse gases, making it a low-carbon option. However, it also presents challenges, including waste management and safety concerns. The development of nuclear technology has enabled large-scale power generation, supporting industrial and urban growth. Nuclear energy remains a controversial but important part of the global energy landscape. Energy storage is essential for modern power systems. Batteries, pumped hydro, and other technologies store energy for use when demand is high or supply is low. Advances in battery technology are enabling the widespread adoption of renewable energy, making power systems more flexible and reliable. Energy storage supports electric vehicles, grid stability, and emergency backup. The development of efficient storage solutions is a key factor in the transition to sustainable energy. Smart grids use digital technology to manage energy distribution efficiently. Sensors, automation, and real-time data help balance supply and demand, reduce waste, and improve reliability. Smart grids support the integration of renewable energy and electric vehicles, making power systems more responsive and sustainable. Energy management systems enable consumers to monitor and control their usage, saving money and reducing environmental impact. The rise of smart grids is transforming the way we use and manage energy. Energy use has significant environmental impacts. Fossil fuels contribute to air pollution, climate change, and resource depletion. Renewable energy reduces these effects, supporting cleaner air and a healthier planet. The transition to sustainable energy is driven by the need to protect ecosystems and human health. Environmental awareness is shaping energy policy and innovation, encouraging the adoption of cleaner technologies. The relationship between energy and the environment is central to the future of human life. Energy drives economic growth and development. Access to reliable power supports industry, transportation, and communication, enabling innovation and prosperity. Energy investments create jobs and stimulate markets, while efficient use reduces costs and improves competitiveness. The evolution of energy systems is closely linked to economic progress, shaping the way societies grow and thrive. Sustainable energy solutions are essential for long-term prosperity and stability. Energy innovations have driven social change throughout history. The transition from fire to electricity enabled new lifestyles, opportunities, and challenges. Access to energy supports education, healthcare, and communication, improving quality of life. Energy systems shape social structures, influencing how people live, work, and interact. The ongoing evolution of energy continues to drive social progress, creating new possibilities for communities around the world. Technological advances are closely tied to energy innovation. New energy sources enable the development of machines, devices, and systems that improve efficiency and productivity. Technology drives the adoption of renewable energy, smart grids, and electric vehicles. The relationship between energy and technology is dynamic, with each fueling the other's progress. The future of energy will be shaped by ongoing technological breakthroughs, offering new solutions to old challenges. Energy access is vital for health and well-being. Clean energy reduces air pollution, supporting respiratory health and reducing disease. Electricity enables medical equipment, refrigeration, and communication, improving healthcare delivery. Energy systems support clean water, sanitation, and nutrition, essential for healthy communities. The link between energy and health is a key factor in development and quality of life. Sustainable energy solutions are critical for global health and resilience. Energy access supports education and learning. Electricity powers schools, computers, and communication tools, enabling students and teachers to connect and collaborate. Clean energy improves indoor air quality, creating safe and comfortable learning environments. The spread of energy systems enables remote education, expanding opportunities for people in rural and underserved areas. Energy and education are closely linked, driving social and economic progress. Energy systems have enabled globalization, connecting people, markets, and cultures. Oil, electricity, and communication networks support international trade and travel. The integration of energy systems drives economic growth and cultural exchange, making the world more interconnected. Global energy challenges require cooperation and innovation as societies seek sustainable solutions. The story of energy is also the story of globalization, shaping the modern world. Innovation is at the heart of energy evolution. New ideas and technologies have driven progress, from fire to electricity and beyond. Inventors and scientists have developed solutions to meet changing needs, improving efficiency and sustainability. The spirit of innovation continues to shape the future of energy, offering hope for cleaner, more reliable power. The journey of energy is a story of creativity, discovery, and transformation. Sustainability is a guiding principle for modern energy systems. The transition to renewable energy supports environmental protection and resource conservation. Sustainable energy solutions reduce pollution, support economic growth, and improve quality of life. The challenge is to balance energy needs with environmental impact, ensuring a healthy planet for future generations. Sustainability is shaping energy policy, innovation, and consumer choices, driving the evolution of energy. The future of energy presents new challenges and opportunities. Climate change, resource depletion, and population growth require innovative solutions. The development of clean, efficient, and reliable energy systems is essential for global progress. Advances in technology, policy, and consumer behavior will shape the energy landscape. The ongoing evolution of energy will determine the future of human life, offering hope for a sustainable and prosperous world. Individual choices play a role in the evolution of energy. Consumers can support sustainable energy by using efficient appliances, reducing waste, and choosing renewable sources. Personal actions contribute to environmental protection and energy conservation. The spread of awareness and education empowers people to make informed decisions. The impact of personal choices is significant, shaping the demand for clean energy and supporting the transition to sustainability. Communities are leading the way in energy innovation. Local projects, such as solar installations and energy cooperatives, support sustainability and resilience. Community action drives the adoption of clean energy, improves efficiency, and reduces costs. Collaboration and shared goals empower communities to create positive change. The role of community in energy evolution is growing, offering new models for sustainable development. Policy plays a crucial role in shaping energy systems. Governments set regulations, incentives, and targets to support clean energy and reduce environmental impact. Policy drives innovation, investment, and adoption of new technologies. The evolution of energy policy reflects changing priorities, from economic growth to sustainability and climate action. Effective policy is essential for the transition to a sustainable energy future. Global cooperation is essential for addressing energy challenges. International agreements, partnerships, and research drive progress in clean energy and sustainability. Cooperation enables the sharing of knowledge, resources, and technology, supporting the transition to a low-carbon future. The evolution of energy systems requires collaboration across borders, industries, and communities. Global cooperation is shaping the future of energy, offering hope for a healthier planet. The future of energy will be shaped by innovation. New technologies, materials, and systems are being developed to meet changing needs. Advances in renewable energy, storage, and smart grids are driving the transition to sustainability. The spirit of creativity and discovery continues to inspire progress, offering solutions to global challenges. The journey of energy is ongoing, with each step bringing new possibilities for human life. The evolution of energy has transformed human life, from fire to electricity. Each new source has enabled progress, innovation, and social change. Energy systems have shaped the way we live, work, and interact, supporting economic growth and environmental sustainability. The ongoing transition to clean, efficient, and reliable energy is essential for the future. The story of energy is a testament to human ingenuity, resilience, and the quest for a better world. As we look to the future, energy will continue to shape human life. The challenges of climate change, resource management, and technological innovation require ongoing effort and creativity. The transition to sustainable energy is a shared responsibility involving individuals, communities, and nations. By learning from the past and embracing new solutions, we can build a brighter, more sustainable future. The journey of energy is far from over, and its impact will continue to define the world for generations to come.